Hey friends, so we're gonna try to implement a weight sensitivity. We're gonna do it from scratch, but I want to show like what I want to implement. So this is like prior app we've been working on and like prior videos, and so we want to implement this specific idea, which so like we have this training set fitted. Fit. Anyway, we want to, so the idea is we're going to tweak like this weight, tweak it the other way. So like we're tweaking the weight and, you know, like it's creating error in the fit of the training set. And like in this particular case, like the error is kind of the same for both training set points, but maybe if, I mean, okay, this one's kind of the same too, but okay, so like this one, it's kind of clear that like the red, like when we tweak, you know, like we're incrementing the weight by 0.1, and it causes larger error for the red training point than the green training point. And here, yeah, like it's a little bit more for the red. So like if we also add another training point and then like refit, okay, that's gonna take forever. Let me refresh. 3 training points. This one's also gonna take forever. Like, I can find one that's easy to fit. That should be kind of easy to fit. Like it has to pull apart. If we make this 30 like a 16, that should be easy to fit. Okay, took forever. So yeah, we'll just look at it again. Here you can see like it's, so like the green training point and the red training point are more sensitive to this weight than this guy. And it's also kind of true, again, like the blue point is less sensitive than these guys. And then up here, yeah, so you get the idea. So, so we want to have like a visualization. I think it's just going to be, we're just going to have like a relatively small neural net, and then we're going to have, I think, just like a matrix. And it'll be a matrix where each row is a weight, and the columns will be points in the training set. And I think, you know, like we'll either like fit or not fit the neural net to the training set. Actually, I think we'll do both, right? Like we'll do like pre-training, post-training. And then visualize the sensitivity of each training point to to the weights. And I guess like the inspiration for that, I mean, like it's the original inspiration, which I don't think still holds, is kind of the idea that if a I guess like it's like if a neural net has either like as many units, or I think as many parameters, like as many parameters as there are training set points, then like it should be able, like a 2-layer neural net or something can convert, like can fit any training set. And so yeah, so like we're kind of interested in like the idea of like the capacity of like, you know, how many like arbitrary training points can like a neural net fit. And so there's roughly an idea that like if a neural net is like at capacity, then like conjecturally every weight, like every training point should be like sensitive to every weight, because it kind of means like every weight, like you can't alter it in any way without like causing like you, so like you can't add like a new point because you'd have to alter one of the weights, and all of the weights are like all of the previous training points are sensitive to all of the weights. So I don't know if that's true or whatever, but we just want to make the visualization now at this point. So yeah, so we're gonna be just putting up a bunch of like matrix canvases, I guess. So yeah, we'll see how far we get. We'll see how far we get. So okay, so we're gonna start from scratch, but I'm using the same HTML file, so I need to call the new JavaScript file, and yeah, I mean, like, there's not, I guess kind of one of the hard parts is going to be implementing the like actually computing the sensitivity, because like every weight we're going to have to like perturb it by some amount and then compute the error. It's also not clear. I mean, there's a number of ways, like you could perturb it like, you know, negative 0.1, negative 0.2, positive 0.1, positive 0.2, and then like take the average error like from each of those perturbations. Or you could just say like, I'm gonna perturb it plus minus 0.2 and take the max. Yeah, I think I'm just gonna do that. So so let's kind of write the so yeah, so we're just gonna have rows, and each row is gonna have two matrices of the neural net being trained and then, or like untrained and then trained, and then it's gonna have two canvases, and then, you know, like we'll do like 5 rows or something. And so each row is like its own neural net. Yeah. So I think we are using kind of like GitHub Copilot. I don't think it's going to like be able to help us that much, but I'll kind of like, I'll just tell it what we're doing. So maybe it will, it might be able to help us somehow. So visualize the sensitivity of each point in a training set to each weight in a neural net. So each row will consist of a you know, new neural net and a new training set. The neural net will map you know, R3 to R3, say, and like the training set will be a set of points in R3. The sensitivity of each point in the training set to each weight is, take a guess, calculated by the difference between the output of the neural net and the, I mean, that's close. To each weight will be calculated by perturbing each weight by a small amount, and then calculating the change in error with respect to the original weight. The error is the Euclidean distance between the output of the neural net and the output of the perturbed neural net and the original output. Okay. Yeah, I mean, that's basically what we're doing. So I'm going to, okay, I was going to see if it was going to suggest something, but I think it's confused. So I'm just going to have a for loop for each row. Okay, so then we need to whoa, it knew. Create a new neural net. Yeah, it doesn't know how to do that. Actually, neither do I, really. So I'm going to copy paste. I mean, we're just using TensorFlow. But, you know, they have like a whole thing where you have to do it correctly. So I don't think we need to compile it, because, well, actually we do, because we are training it. Never mind. And so yeah, like we're gonna map R3 to R3, I guess. And we're going to not have, so this has like one hidden layer, and we want the kernel initializer to be the default and also the bias, and we want the activation to be 10H. You know, like, everybody likes ReLU, but I'm like, hey man, I'm a 10H. You know, I date myself because I use 10H. No, I hear for like small neural nets, like 10H is better because it's more smooth or something. I don't know. What is the justification for like ReLU? Who knows? Okay, yeah. So next we need to create a new training set. This thing is a genius. Like, it knows exactly what I need to do. But yeah, I'm just going to reuse this code. Yeah, we need this. So we're just going to copy paste that over there. So this just creates an array of random integers with no duplicates. That's kind of a key. Also, it runs in quadratic time because of that step. So it's very inefficient, and you would fail lead code. You would fail lead code if you... But, and then you wouldn't get hired at a FANG, you know? And you'd be in... Then you wouldn't, so yeah, so don't implement it that way. So, create the training set. Right, because you have to do like a little bit of trickery stuff here. In particular, oh, yeah, no, no, we don't need to do that. Yeah, because the prior stuff was, we were using a grid. And then we were indexing into the grid. And we don't need to do that. We don't need to index into the grid. We can just directly call... Okay, so actually you don't even need this. So we can still get hired at FANG, because we don't need that. Yeah, how do you... Okay, so I actually don't know how to create a training set. Like, it just needs to be a... well, it just need... Okay, yeah, so it's just going to be... X is going to be... Yeah, close. Why did it suggest this? Oh, I think in a prior... Yeah, I did do that somewhere. Okay. It's giving me the Boolean hypercube in 3 dimensions. But we don't really want the Boolean hypercube in 3 dimensions necessarily. So we're going to say like random normal. Is it better to use uniform or normal? Because like a normal samples from the surface of a hypersphere. Although like we're in 3 dimensions, so it's just like a regular sphere. Does it though? Or do you have to normalize? But I don't know, because I don't want to... We're just going to do uniform. Yeah. Yeah, we need to know the number of points. I'll just pull... I'll pull all of these out as... what do you call these? Like parameters or something? So, training set size is what I shall call it. Training size, that'll work. 100. No, that's way too large. That's way too large. We'll do 5. And then this needs to say training size, and 3 is the dimension. And then arbitrarily, we're mapping R3 to R3. So that is like your training set. Do you have to like declare it as a training set? I don't think you do. I think you can just pass that directly to fit. Yeah. Yeah. Okay, so the next thing would be before we train the neural net, we want to create the actual visualization. So I think that's kind of the hard part. So we're gonna put that in its own little function, I guess. I guess it'll just... I guess the function will just like return a... will return a canvas with the visualization already visualized. I mean, that sounds as good as any. So, yeah, display the sensitivity visualization. How's it gonna do this? Whoa, no way. Did it do it for me? Is this right? There's no way that's right. Let me check this out. Okay, get weights. That's kosher. Sensitivity, good, okay. For weights.length. The thing is that this gives you an array of arrays. Or no, like it gives you an array of tensors. But I think that's fine. I think it's handling that. So it's iterating through weights.length. See, like it knows to use like tf-tidy, and like I never use that because I don't even know what the heck it does. I think it like garbage collects for you or something. I don't know. Perturbed weight. Like what the heck? This is a weird one. Like it's data sync, as far as I know, transfers the weight from your GPU to your like CPU RAM. And so like but then it's like sending it back to the GPU. So that doesn't make any sense as far as I can tell. And then it's calling weight.size, which is not a function. But then it's creating its delta, and then it's weight.add the delta. Yeah, no, this is not correct code. Neural net.set weights. I mean, what it is it's optimistic code. But it's so okay, like it calls perturbed weight twice, or like it declares it twice. That doesn't make sense. I don't know if evaluate is a function in the API. That would be good to know, actually. But no, that's also not what we want, because we were gonna do individual. Yeah, okay, so this isn't right. This isn't right. It was close. Like, it was a good attempt. It was a very good attempt. But so we're gonna pull it out into its own function. Okay, so yeah, so let me just, okay, so create yeah, so like, okay, so like create a function that takes a neural net, okay, and a training set, and returns a neural net that maps R3 to R3. No. That returns a canvas element that visualizes the sensitivity of each point in the training set to each weight. Yes, that's what we're doing. Visualize sensitivity. Net, training set, canvas. Okay, good. Get context. Good. Width is going to be the width is just going to be the also the training set needs to be in terms of x's and y's. Train x, train y, and it's so the width of the canvas is going to be, the width is the number of columns, but we need to set the width to be just the number of training points, but that's going to be shape because it's a tensor. Actually, yeah, or you could say training size, that's fine. Canvas height, yeah, that's going to be incorrect because it's the number of weights. Yeah, so I have like code for doing the weights because like it's non-trivial, because when you call neuralnet.getWeights, it gives you you have two elements for each layer, and like the first element is a two-dimensional matrix, and the second element is a one-dimensional bias vector. So like you have to handle that when you're indexing into the array. But I do have code for doing that somewhere. Yeah, I just called it update weight. There it is. So update weight, layer index value, and I think I also had increment weight to make it easier. Do I have increment weight? Increment weight. Layer index amount to increment. Yeah, so the thing is you so when you're iterating, you have to know the number of layers, and then you also have to know if you're on like an even or an odd index, because if you're on an even index, you're indexing into a two-dimensional array. And then if you're, yeah, that's pretty annoying, I'm not gonna lie. But so I think we'll just copy paste this. So then also, yeah, like the total number of weights. Is there a way to figure out the total number of weights? You would think there would be. I think, yeah, let me look that up, because otherwise we have to implement like counting the number of weights, which I don't want to do. Okay, so like tensorflow.js API. Good. Okay, number of weights. So you just have summary. But does that just like output it as a string? Okay, let's see what that outputs. Or like, is there like git? Or, yeah. Okay, so let's see what that does. Like, does it output to the console at all? Right. Learning, oh my god. Where's learning rate? 0.05. Trainable yeah, but that's like a big string. That's like a giant string. I can't handle that. Total params 17. I know, but like I wanna you know what you can do is yeah, it's not that, I think you can implement it easily actually. Copilot might even know how to do it. Counts the number of weights in a neural net. Let's see if it knows how to do it. It's not looking good. Yeah, I mean, you could do it like that, I guess. Yeah, but what needs to happen though is that this needs to be it needs, because it's a tensor, so it needs to be yeah, that would be better actually. Yeah, that's better. Yeah, that's way better. That's what I was gonna say. Yeah, that's better. Okay. But then you need to increment this by 2. And that needs to be minus 2, I think, because we're going by 2s. So let's check that this says 17. 17 parameters. That says 0. That's not a good thing. That's not right. Oh, this just gives you the layers. Okay. Yeah, okay, so never mind. That's plus equals 1. Plus equals 1. Okay, try again. Dang. Alright, what's happening? Net layers. It's giving us 2 layers. Good. And then that should work. Like, why is it not working? WP. Wow. Jeez. So like it was correct. It was originally correct, and then I corrected it to make it wrong. That's gonna be like an increasing thing that happens in the future. Is like AIs are gonna be correct, and then the human is gonna make it wrong. So right, so we're good now. So I don't need to do a summary. And 17 weights. Nice. Okay, so we're going back to the number of rows is going to be count weights of the net. times 2. The 2 is just because like it's going to be 2 pixels. Okay, so yeah, okay, so then we're then going to iterate over the points in the training set. So yeah. So for I equals 0, whoa, it just did a bunch of stuff for me. Hello. What did it do? No, Mr. Neural Net, or Mr. Copilot, that was wrong. That was very wrong. So we're going over each training set point. Tx. I mean, we are going to need this. Wait, are we? No, we don't. No, yeah. Okay, so tx dot shape 0 I plus equals 1, and wait, is that right? Is this right? See, this is like problematic because like, you know, I was like trying to figure it out on my own, but then I have to figure out like if this is correct. Because it's like a lot of times like it's subtly incorrect. Like I would describe Copilot as like optimistic because like it'll just call functions that like don't exist or whatever, but like they should exist, you know, like in a more perfect world they would exist. Alright, let me check this out here. Fill rectangle RGB error times 255. Yeah, but that's, we need predict tx, subtract ty. No, the way calculating that error, that is not correct, my friend. That is not correct. But like the incrementing, no, this is also not correct. Okay, yeah, this isn't right. Yeah, that's not right. Okay, I mean it's close, but so we need to increment for let layer equals 0, layer is less than neural net dot get layers. Is that, how do you get all the layers? What, wasn't I just doing that? Oh, yeah. Neural net dot layers dot length. What's the difference between layers and get layers? Oh god. Okay, I have to figure out if this one is right. Okay, so it correctly gets... Okay. So it, okay, so, oh, so it's going to separately loop over the weight array. Yeah. Okay, it's close. Oh, no, 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 no. No, that is cool, because this will be a two-dimensional JavaScript array. So it is correctly looping over a two-dimensional JavaScript array. And then, and yeah, it's computing the sensitivity on the total loss, but I want like per, I mean, you could do that. What is this X and Y though? I don't understand what this is. Oh. Okay, so that's for the row and the column. Okay. And but then like it's creating it's saying like the width of the rectangle is going to be a function of the sensitivity, which is not what we want. But I times 2, that's correct. Layer times, I don't think this is correct. I think the easiest way to do that would just be to have like a weight counter. And then, no, that wouldn't, well, yeah, I think so, because so I'm gonna rewrite this in terms of the weight counter, which it figured out on its own, which is freaking amazing. Now this is not right here, so I'm gonna say initial error. Yeah, I'm gonna have to delete the rest of this, but so it's gonna say initial error is going to be, yeah, that's exactly right. Okay, and then increment the weight. This is so freaky. This is so freaky. Like, it knows exactly how to do it. Oh my goodness. Increment the weight, compute the final error. Yep. Delta, yep. Fill style, fine. Draw, rectangle, yes. And that's it. Oh yeah, you want to reset the weight. Wow. I didn't even think of that. That's it. That's the whole thing. Jeez. So, given that information, it'll probably do this differently. Yeah. Initial error. Increment weight. Yep. Final error. Yep. Yep. Oops. Oh my god. That's so amazing. Okay, so that should like work. And do we just want to like add the canvas to, Oh. This needs, it needs to return the canvas. Returns the canvas, thank you. Well, you don't want that to be a const, do you? Oh no, I guess the const is like scoped to the iteration, is it? I don't know. Visualize sensitivity, append child. Okay, you're cooking. We're cooking. Neural net is not defined at visualize sensitivity at 32. What? 129. What's this saying? NN is not defined. It's totally defined, bro. It's defined right there. Why doesn't it think that's defined? Or is it somewhere? 68. Oh, because that needs to say net. Yeah. We'll just change this name. Yeah, okay, see, it messed that up. I'll keep it net, because I don't know if it'll overwrite the other thing. Okay, so I gotta go through and change all these. Oh my god. Net. Alright, now we're... Oh, dang. Cannot read property of undefined. At 75. Okay, so this isn't actually a thing. I feel like it should be. I mean, why isn't that a thing? Wait, I don't think you can index like this with a tensor. Can I can just say tf.subtract. tf dot... I can subtract these two. I don't know if they spell it out or not, but so I can pass the whole training set, which is fine. Yeah, do that. Yeah, that's what I was gonna do. That's what I was going to do. But then it needs to say I. This needs to be I. And so then we need to fix this. Is it gonna... It's gonna autocomplete? No? There it is. Yeah. No. No, we don't need the mean. You don't take the mean, because I mean, there is no mean because it's a single training point. Yeah. Oops. Autocomplete, please, please, please. Yeah. Okay, like I gotta go eat food and stuff. Oh my god, it's sub. I was wondering about that. Of course it was the opposite of what I did. Okay, here we go. Now we're talking. Oh, it's doing something. It's doing something. Oh, you know what? We never actually, like, train. Do we? Yeah, we never train, but that's fine. Okay, it did something. Are those each canvases? Those are each tiny little canvases. Yeah, okay, so what I'm gonna have to take a break, but like what we're gonna do, what we have to do is, scale. I'll write a little to-do here. Add a slider to control. Yeah, sure, that sounds cool. Add a slider. Oh, yeah, sure, why not? I mean, none of this is what I was gonna say, but change the number of neural nets. Now we don't want to change the number of neural nets. So we need to norm. Yeah, well, like, yeah, normalize like the error. Get a color palette for the error visualization. We don't actually need these. They were cool suggestions though. Okay.